Okay. Today we shall be developing. Today we shall be developing Arch, GARCH, GARCH, EGARCH, and TARCH model. TARCH model. We shall be developing Arch, GARCH, EGARCH, and TARCH model using EVIEWS, and later we shall compare all these five models to find out which one is the best. So that is our task. Today we shall be developing Arch, GARCH, EGARCH, and TARCH model using EVIEWS, and later we shall compare all these five models to find out which one is the best. And here we shall choose AIC and SIC criteria to decide which model is the best, and lower the value of AIC and SIC, better fitted the model. So that is our guideline. That means lower the value of AIC, better the fitted model. So that is the guideline. Okay. And here we can see we have the variable BBR. You can see from here, right? We have the variable BBR. Okay. Variable BBR. You can see from here, right? What is BBR? Bangladesh bond return, right? Bangladesh bond return, and that is BBR. And what is C? C is the constant, right? C is the constant, and our sample size is 200 days. Our sample size is 200 days. So that is our sample size. Okay. Now first I run the model. So what is our model? The first model is like this. The first model, okay, so here we assume that at the very beginning we assume that our variable, that is BBR, is stationary, right? We assume that BBR is stationary, and if it is not stationary, if it is not stationary, then we need to convert it into stationary, and only then we can estimate ARCH and GARCH model. ARCH and GARCH model, meaning that our variable must be stationary. Only then we can run ARCH or GARCH model and so on. And here we assume that our variable, that is BBR, Bangladesh born return, is stationary. Okay, so now we can run the model. Okay, and what is our model? Our model is, the first is the dependent variable, then I take the constant, right? First is the dependent variable, right? Then the constant. So that is our model first. And here there is no other variable. That means only these two, BBR and constant, and there is no other variable. Okay, so I first run the regression line. Okay. Okay. So I go to quick estimate equation. So first I put BBR, then I put constant C. So that is my model, and here BBR is the dependent variable and C is the constant. Okay, I run the model now, and our sample size is 200. That is our sample size, meaning that 200 days data. 200 days. So that our data is from 200 days. Okay, then I run the model. Okay, that is my model, and dependent variable is BBR, Bangladesh born return, and it is the constant, right? And this is the model. Okay, then I check the residual of this model. Okay, so where is the residual? You can see from here, it is the residual of this model. So I click on the residual, it comes up here. Okay, it is the residual. So you can see from here, the residual is this one, this color, the blue color, right? It is the residual of our model. And here what is happening, you see, so and what is this? 200 days. This is the day number 1, day number 2, day number 25, and day number 200 days. 200 days, right? Okay, and these are the residuals, right? The fluctuation is the residuals. Yeah, so this one is the fluctuation of the residual. Okay, from here we can see from day 1 until day 40, right? From day 1 until day 40. So here is the fluctuation is very low, right? You can see the fluctuation is very low for 40 days, about here, right? Okay, but again from the 40 days, so the fluctuation has gone up, right? Has gone up from here to here, meaning that from 40 days until 75 days, the fluctuation is high for long period. And again from 75 until 150 days, the fluctuation has gone down for long period, from 75 days until 150 days. The fluctuation has gone down. Again, from 150 days until 200 days, the fluctuation has again gone up. So what is the symptom? So here what is happening, that is happening here. Meaning that periods of low volatility, tend to be followed by periods of low volatility for a prolonged period, right? For a prolonged period. So meaning that periods of low volatility tend to be followed by periods of low volatility for a prolonged period. Meaning you can see from here to here, so the low volatility is followed by another low volatility for a prolonged period. Again, from here to here, you can see, from here to here, you can see this gap. From here to here, also periods of low volatility tend to be followed by periods of low volatility for a prolonged period. Okay, again the periods of high volatility is followed by periods of high volatility for a prolonged period. So here also from here to here, you can say from here to here, suppose from 40 days until 75 days. So high volatility is followed by another high volatility. And also from here, you can see from here, so from 150 days, right? So high volatility is also followed by another high volatility. So meaning that from the day 150 until the day 200, one high volatility has been followed by another high volatility. So when these things happen, when this thing happen for residual, then we have all justification to run arch family model, right? When this thing happen for residual, then we have all justification to run arch family model. Okay. But we can double check the whole thing. We can double check the whole thing by appointing arch model, right? By appointing arch test, not model, by appointing arch test. Okay, but we can double check the whole thing by appointing arch test whether we should run arch family model or not. Okay. Okay, now the question is that how to run arch test. That is the question, how to run arch test. Okay, here I go to view, then I go to residual diagnostic, then I go to the heteroscedasticity test, right? From here I click it. Okay, from here I choose arch model, arch test. I choose arch test and I click OK. Okay, so this is the arch test. You can see from here, and you can see from here the observed R square, right, and the corresponding p value is how much? The p value is here, is around 0.0019, right? And this p value is less than 5%, less than 5%, meaning that we can reject null hypothesis and we can accept alternative hypothesis. Okay, so and what is our null hypothesis? Our null hypothesis is there is no arch effect. And what is our alternative hypothesis? That is, there is arch effect. Okay, there is arch effect. So here we can reject the null hypothesis, meaning that our model has a arch effect. So we can run the arch family model such as GARCH, right? Then EGARCH and the TARCH and so on. Okay. Okay. So actually here what has happened? What has happened here? Okay. Number one, what has happened? Number one, periods of high volatility has been followed by periods of low volatility. What has been happened here? Periods of high volatility has been followed by periods of high volatility for a prolonged period. At the same time, period of low volatility has been followed by the period of low volatility for a prolonged period. So we can easily run the arch model. And secondly, after running the arch test, we have found that there is a arch effect. So we can easily run arch family model. We can easily run arch family model. Okay. Okay. So I go to estimate. You can see estimate here, right? I click on the estimate. Okay, then this is my dependent variable, and this is the constant. And from here I choose the arch family model, the arch model that I choose. And you can see here are many options. Okay, so suppose first I run what model? First I run arch 5 model, meaning that suppose I make GARCH 0 here, right? I make GARCH 0 here. Okay, I make GARCH 0 here, and arch I make 5, right? That means 5 arch and 0 GARCH, and I choose normal distribution. Then I run this model, and here we shall always choose the normal distribution to compare among all the models. Okay, so I choose 5. Then I can run the arch model, right? Then I can run the arch model.